Hello everyone. In this series of videos, we will learn how to use GeoGebra 3D to visualize and implement core concepts of engineering electromagnetics. As you know, electromagnetics is inherently three-dimensional and it is vector-based. So instead of only solving equations on paper, we will use simulation to understand the geometry and physics behind them. So here I'll be using the simulation platform, which is called GeoGebra. Uh, why exactly I'm choosing this for EMW is that the GeoGebra 3D allows us to represent vectors clearly in 3D space. It helps us visualize the direction and magnitude, and it also helps in dynamically varying the parameters using slider concept. And we can verify analytical results visually here. Uh, in general, I can say in electromagnetic, visualization is not optional, it is essential for us. And one more thing is that the GeoGebra 3D simulation platform, it is an open source software which is available for free. You can use it either on desktop or you can use it even in your phone. You just have to open the internet, connect to the internet, open the software online, and you can work with it. Okay, so I'll show you the interface now. There are two components of GeoGebra. One is the normal GeoGebra, the one is of GeoGebra 3D. The normal one gives you option to plot 2D vectors and the other one is the 3D vector. Since in electromagnetic we are going to deal with three-dimensional vector space, we will be working with the GeoGebra 3D. Okay, so you just have to type the GeoGebra 3D in the Google presenter and you have to click on the first website that you get. Okay, this is your web page. Just have to open it. You have GeoGebra 3D calculator. Okay, so when you open it, you'll be directed to this page where you'll see three important components. This is the algebra view where you can enter all the data numbers from here. And then you have also options for tools. Additional tools can be imported from here. We'll not be using this. This is for the basic algebra, vector algebra. For electromagnetics, we'll not be dealing with these tools. And then this plane you see here is your 3D view of the vectors. So three-dimensional, you have x-axis. The green one will be the y-axis, the red is the x-axis, and the blue is the z-axis. So x, y, and z components. Okay, so you have the algebra view, you have the 3D graphics window, and enter the inputs. You want to define a vector, you can enter it using this input bar. You can type here any vector values and you can enter it. Okay, and then you can rotate this three-dimensional model by dragging the mouse. You can rotate it, and you can also zoom in and zoom out using the scroll button of the mouse, or you have the options for zoom in, zoom out on the bottom corner here. You can also fit it to the standard view. So it gives you the standard view where you will be able to now plot the vectors. Now we'll see how to create basic objects here. First is I want to define a single point on this 3D space. I'm not directly jumping to the vector here. First I'll create a point A which is made up of the three axes x, y, and z. Or I can just call it as a scalar value which has magnitude but no direction as of now. So how do we define this point? So I want to call the point as A. So just click on this input bar, type A there. I'm sorry. Yes, here. Type A and assign the x, y, and z axis values, its position. You have to tell where do you want to put this point on this plane. Okay, so let me take an example. I take 3, 2, 1. The x value is 3, y is 2, and z is 1. So at that, when I type it, you'll be able to see that a blue point has occurred here, right? This is nothing but the point A which you have just now entered. So if I press enter, you'll be able to see the label as well. So this is the point A. It's a just a point in space, scalar value, which is positioned at that particular x, y, z value. Okay. Now this has only magnitude. If I want to change it, if it is just a point, simple point in space, If I want to convert it into a vector which has both magnitude and direction, I need to now use some inbuilt function. So the inbuilt function for creating a vector is, you just type the name itself. You have a lot of options here, different types of vectors you can um, generate. I want a normal vector here, and I'll be using, when you select this vector, no, you'll be having options here, whether you want to convert a single point into a vector, or you want to mention, or you want to create a vector between two different points. Okay, so you can choose any one of them. I'll just take this vector point. I want to convert this A into a vector. Okay, instead of just being a point in space, I want to convert it into a vector now. So as soon as I do vector of A, before even I enter, press enter, you see that the point has now changed into a vector. Since I've converted a single point into vector, and you should know the concept of vector, that it is a line joining two points in a particular direction, right? It should have a starting point and it should have a ending point. So when I specify a single point to be converted into a vector, the starting is always assumed as origin. That's why the line is starting from center. Okay. Origin means x is 0, y is 0, z is 0. So line is starting from center and your end point is A. So you have now a vector which is starting from origin moving towards A. So the direction arrow is telling you the direction in which your vector is pointing. Okay. So whenever you talk about electromagnetic waves, the direction matters here. Okay. So what you enter first will be the starting point. What you enter next will be the ending point. Okay. This is how you can create a vector in GeoGebra. One more way I would like to show is, here I gave a single point, right? If I want to create a vector using the second option, that is start and end point. Okay. So start point is the point where your line starts from. So I'll just write, I again want origin only. So 0, 0, 0. Origin means all the x, y, and z values are zeros. And I want the line to end at point A. Okay. So I'll delete this one. I'll keep this. Enter. So this is another way of converting the point into a vector. You can specify the starting point as origin and you can give the point A as your end point. So it is going to create a line from origin to A in the direction of A. Okay. So this is how you can define vectors, create vectors here using this software. Now coming to the next concept, next important thing is, now whenever you are going to, you're trying to simulate any electromagnetic concept, like it might be force or you might be trying to find out the electric field intensity. In such cases, what happens, you will be having a parameter in the formula which is your distance r, and you have one or more parameter that is charge q, right? Instead of finding the value of force for a fixed charge and fixed r, you want to see what happens to the electric field if I keep changing these distance and charge values, right? I hope you're getting the point. That is, I want to, during runtime, I want to dynamically change these parameters and observe the output. So how do we do that? So we have a concept called slider tool here. We have a tool called slider, which creates a slider, or you can say it creates a range of values for any parameter, and you can dynamically change its value during runtime and observe the output. So I'll explain it clearly using an example. How do we create the slider? Again, you have the inbuilt function that is slider, and within the bracket, you have to give certain parameters. So now first you have to name the slider, okay? Let's give a name to the slider. I'll call it a small a, comma. Then you have to mention what is the minimum value from where you want to start. So I'll give it as 0, and the end value, I'll give it as 5. Okay, let's say this is the range I'm taking. If at all the value is not changing, what you can do is click on this, change the value. I want 0, right? I want it to start from 0, so I have changed it to 0. This is a slider. You can vary this value, and accordingly you will be able to see the variations happening in the output. But even if now I change the value of small a, you see nothing is changing in the graph. Okay, even when I change this, please observe the graph. There is no change happening in the graph. So how do I connect it to graph, right? For that, what you have to do is, you have to again take this vector A. Now, what you have done is you have given x, y, and z values independent, fixed values, 3, 2, and 1. But instead of that, I'll make it as 3a, 2a, and 1a. Now what happens is, your x value is scaled version of a. For example, if a is 0 initially, if I take a as 0, x will be 3 into a, that is 3 into 0, 0. Y is 2 into 0, 0. Z is 1 into 0, 0, which means the first point is going to be origin. You see now, I have changed the a value to 0, right? Small a. So the vector has, it has come to the origin point. Capital A, you see, the vector has come to origin point in the graph. Now I'll change the value of the slider. Please observe the graph and see how the vector is changing. Okay, so in varying the slider value, you see the vector is now increasing because you're scaling the XYZ values with respect to slider. Okay, this is how we can vary the value of XYZ and observe how the vector changes. I'll give the negative value also here. Okay, instead of 0, let me start from -5 to +5, and now we'll vary it. Yes. When I give positive values of 5, let me start, go back to 0 initially. This is the origin point now. Please observe the graph. It is at origin right now. Okay. If I go towards positive side, +5, it is increasing on the positive axis. Now I'll reverse this. I'll move the slider towards the negative side. See, the direction changes, right? Because you're now scaling with minus values. You're now scaling with minus values. Your vector is becoming negative. Okay, so it is now going in the opposite direction, right? This is how we can use sliders in the later concepts also. You want to find force between two charges and you want to check what happens when I change the distance, how the force is changing, right? You can use sliders for charge as well as distances. So that is the concept of slider. So we'll stop here in this video. In the next video, we will begin with the vector algebra, which forms the mathematical foundation of electromagnetics. Thank you.